We had conservation of mass. We also have conservation of energy. Energy cannot be created or destroyed. It can be converted from one form to another, but the energy of the universe is constant. You cannot create energy. Some forms of energy are more useful than others, and so you can take a form of energy that is less useful and convert it into a form of energy that's more useful, but you cannot create or destroy energy. There's 6 forms of energy: heat, light, electrical, mechanical, chemical, and nuclear energy. And these could be categorized into either potential or kinetic energy. So energy is involved in physical changes, changes in state. So if we have liquid water, 1 gram of liquid water, and we want to turn that into steam, what are we going to have to do to it? We're going to have to heat it up, put it on the stove and boil it. We're putting energy into it. Putting energy into it increases the movement of those particles, and eventually they get enough energy that they can break loose and move around. And so they become a gas. If we take the steam and take energy out of it, we can cause it to condense back into liquid water. The amount of energy needed to vaporize 1 gram of water is 540 calories. The energy that's released by condensing 1 gram of steam is 540 calories. It's the same amount of energy regardless of which direction you're going. There's an analogy floating in my brain, and it's just not quite coming out. I'm thinking about selling things and buying things. Pawn shops don't work because they don't conserve energy. Yeah, it's on the fritz. My analogy maker's on the fritz, sorry. Energy can also be involved in chemical changes. Here we have water and we're passing electric current through it. You can actually do this with a 9-volt battery in a glass of tap water. And you'll see bubbles form at the terminals of the 9-volt battery. What's happening is you're passing electrical current, electrical energy through the water molecules, and you're decomposing the water. You're making hydrogen gas and oxygen gas. So there is energy put into it to cause this to happen. If we take those 2 gases and combine them back into water, energy will be given off. The same amount of energy will be given off. The direction doesn't matter. So I suppose we could, let's go with the pawn shop thing and show how it's not like this. So the way pawn shops work is you're desperate for money, and so you maybe take your tuba that you're not using anyway, and you take it and you pawn it, and maybe they give you $50. And then later, things are better for you and you want your tuba back, and you go to the pawn shop and you say, here's my $50, I want my tuba back. What are they going to say? No, you need to give us $100 to get your tuba back. You're like, what? Right? Because that's how they make money on stuff. But with energy, if you sold the tuba for $50, you could buy it back for $50. There's no markup. There's no loss of money involved. Okay? If we combine these 2 ideas, conservation of matter and energy, we get the very creatively named law of conservation of mass and energy. So this states that the total mass and energy of the universe is constant. Because it turns out that in nuclear processes, you can convert matter into energy. And that's where Einstein's famous equation, E equals mc squared, comes from. Einstein's theory of relativity. Energy equals mass times the speed of light squared. You can turn mass into energy. You can't do that in this building, though. We don't have the facilities to do nuclear chemistry. And so we can, in normal chemical processes, we can look at law of conservation of mass and law of conservation of energy separately. But if you get into a nuclear process, you have to put them together. But then that's true for everything.